So what we're doing here, solving proportions. First up, what's a proportion? A proportion is two equal fractions. 3/4 equals 6/8 is a proportion. Two equal fractions. I've got no algebra here, but how I know it's a proportion is that its cross products are equal. So we want to get that down. Okay, and cross means like crisscross, and products means multiply. So what that means is 8 times 3 is going to equal 4 times 6. And of course it does, because they both equal 24. So if we want to generalize this for any proportions, doesn't matter, we just remember cross products are equal. If I've got, say, two algebraic fractions, a over b equals c over d, I just need to know that if I multiply these two products together, they're going to be equal. So a times d is going to equal b times c. And then in algebra, without the times sign, it just means a times d equals b times c. That's our rule right here for proportions. So for some examples, because of this concept, it doesn't matter where the x is in the proportion. And that's kind of the beauty of this. It doesn't matter where it is. So when I do this, I go, oh wait, cross products are equal. So 5 times x, that's one cross product, is going to equal 4 times 10. 4 times 10. So 5x equals 40. Okay? So then x must equal 40 divided by 5. That gives me 8. And of course, if I substituted that 8 back into my proportion, it works out. 8 times 5 is 40, and 4 times 10 is 40. My other examples aren't going to have nice whole numbers, so that's okay. Let's look at another example. So here's what I mean by it doesn't matter where the x is. All you need to remember is that you cross multiply. And this time I'm going to leave out the times sign and just do 35 times x equals 7 times 21. And I work out that 7 times 21, 147. And so to solve for x, this number is not going to be as clean as the other one, but that's okay. I'll get 147 divided by 35. So I get a 4.2 for my solution there. Now, what if I have something like this? I got 3x over 5 equals 12. You say, wait, that's not a proportion. Your definition of proportion was two equal fractions. Okay, well remember, this 12 is kind of like a fraction in disguise, because really, it's just 12 over 1. And then we can be happy that it's a proportion. All right, 3x times 1. 3x times 1 equals 5 times 12. 5 times 12. Oh wait, 3x times 1 is just 3x. Autofocus. And 5 times 12 is 60. That means x is going to be 60 divided by 3. 20. Okay. Not too bad. Let's look at another one. So suppose I have this one. Okay, even though it doesn't look like a proportion, we put it over 1. Now we cross multiply, and I'll do it under here. 2x minus 1 times 1 is just 2x minus 1. There's nothing changed there, because anything times 1 is just that anything. And 4 times 5 is 20. Now I have a two-step equation, which we should be familiar with. Add 1 to the other side. You get 21. And x is going to equal 21 divided by 2. 21 divided by 2 gives me 10.5. Let's get some little bit more difficult examples, but it's the same process each time. Let's try some of these. So for this guy, it looks really hard. All right, it looks, but we just, we multiply these two together, and even that, when I say 7 times 2x minus 1, we've got to multiply that 2x minus 1 in brackets. So we do the whole thing, not just the 2x. And it's going to equal these guys multiplied together. 10 times x plus 1. And remember, in algebra, 10 next to a number next to a bracket means multiply. There's little invisible times signs right there. And now we're going to, I'm going to expand brackets on both sides. 7 times 2x and 7 times negative 1. And we get 14x minus 7. And then when I expand these brackets, I get 10x plus 10. Okay, now I'm back to that step from a couple lessons ago where I have variables on both sides of the equation, and I want variables on one side of the equation. So one way to do that is to swap these terms and change their signs, like this. That's a positive 10x, make it a negative 10x on the other side. That's a negative 7, make it positive 7 on the other side. And that 10 didn't change, so it doesn't change signs, and neither did that 14x. Now, I'm going to collect like terms. Collect like terms. And I told you this was pretty tough. This gives me 4x, and this gives me 17. Now that's not going to be a pretty number. It's going to be an okay number. It's just not going to be a whole number, because that's 17 divided by 4. And I didn't use the division sign, because I can write 17 divided by 4 as a fraction. And if we don't like it as an improper fraction, I guess we could write it as 4 1/4. Okay, and if we don't like it as 4 1/4, we could write it as a decimal as 4.25. Okay, whatever you fancy there. Okay, so I'll give you one more to try on your own. See if you can handle it. Go ahead and try this one on for size. There you go. Try that one. And I'll pause it and see if you can get it. What Nick got is on the money. Yep, he expanded those brackets right there, got 3x minus 3. Shifted that 3x over to the other side, making it negative 3x. And when I collect these like terms, it just comes out to be 1x. So I don't have to divide anything. It just simplifies down because 1x is the same as x. Yeah, that's good. Well done. Okay.